Hello, everyone. Nice to meet you, and thank for the community to have me here. So today I'm going to present building secure and trusty works platform with confidential computing, and also introducing open source project called Manatee. It's also under Linux Foundation. So before I go into detail, just a brief about myself. That I work for TikTok right now as an open source advocate. And so these are my personal and work-related interests. Something about open source, PT, secure data sharing. And this deck is going to be available on the website. Yeah, so because of the limited time, I may not able to cover all of them, but if you have some questions about my topic after the session, feel free to reach out to me. Yeah, so this is going to be today's content. So firstly, I'd like to introduce what confidential computing is, because it's one of the emerging technology. And secondly, I like to touch how to do data collaboration and why it's hard and what do we need. And also moving to existing approaches. And lastly, talk about our open source project called Manatee, and also a bit of demo. So let's start with the question. So I'm not going to ask you guys, but I just want you to think in your head. So let's imagine your application is running on a server and processing some data in the memory. And for example, let's imagine attacker physically enter the data center and somehow have the access to your physical box and take the memory out. So would they able to see the data? And if so, how can we protect against this? So this is the question I like to address today. So the answer is actually yes, because currently the computing, there's no physical cryptography in the memory side. So that's something I like to explain like following session, following slide. So then what is confidential computing? So this is the definition from Confidential Computing Consortium. And this is also organization on the Linux Foundation. So basically, confidential computing is protect data in use by performing computation in a hardware-based, attested, trusted execution environment. So in an easier way is that the technology itself is having the key from the CPU layer and encrypt the data while it's in the memory, so that if your application or attacker have some access to your data in the memory, it's still encrypted. So that way it provides confidentiality. That's why it's called confidential computing. And because it uses the key, it can provide the attestation service. Yeah, so I think everyone familiar with the first one or two section, like data at rest, because when you store the data, everyone usually apply the security measures there, like encryption under the database and file system. And also when it comes to data in transit, everyone probably knows HTTPS, SSH, so we are all familiar with it. But data in use is something not really well implemented in this world. So this is something confidential computing can help. So protecting data, why is it so difficult? Because there are so multiple factors can access your data. So for example, let's say your web server is hacked, and then they can technically move to other services. It's called like a lateral movement. So in this architecture, if any point of your server or service is breached, they can actually have an easier access to go to other services. And so basically, once the service is exposed to the vulnerability and some other person have the access, illegal access to your system, your entire service is in a little bit unsecure situation. And most importantly, even your employee can actually misuse their access to access some data. Yeah, so this is your application in the physical machine, and this is your data. But technically, another app can actually see your data because it's not encrypted. And let's say your operating system also hacked by someone else, and they can actually go to your data and see it. And even your hypervisor and everything, and of course other operator as well. But with TE, computational computing, the concept is the CPU has the key so that the data is encrypted. So by doing that, you can apply some code policy. Okay, only this app should be able to access this data, not the other application, not the operating system, not the hypervisor. So this is the concept that TE, computational computing, can provide. And also, I think I will just briefly explain this. So this is the concept of attestation. So I think you can think of HTTPS, right? So when you go to website, you see the address bar, it shows the green mark. And that's happening because the browser trusts the CA, and the CA, trusted by the authority so that they can prove the website you're accessing is verified. So it's actually a similar concept because the CPU has the encryption with a private key, and you can go to the CPU vendor like Intel, AMD, then get the public key so that you can verify the code and the testing you are doing it. So in a simple way, so remote user going to the TE environment, like your code point, hey, I send you data over this secure channel. Okay, so here's a proof that I'm a TE you are expecting. So with computational computing environment, you can confirm the application you are running is actually executed in a trusted environment. So that's the concept of attestation. So I think this is the basic concept of computational computing and how TE works. And I'd like to introduce some use case with our open source. So first use case is data collaboration. So what I mean by that is that, so in the old days, when you think about data, you may have the data yourself, and you have the computing yourself, and you basically run it. So there wasn't that much of the collaboration before. But these days, when you look at it, someone has the data, and I need to use it, but how can I use it? I need a computing somewhere, and I need to use some SaaS provider for data warehouse, things like that. So there are too many multiple parties involved in these days data collaboration. So this is one of the challenges. And another challenge is also compliance and trust. So how can I trust that person having my data and doing what to do, right? So there hasn't been enough trust and compliance and the supporting technology. So TE can help address this kind of issue. So maybe briefly talking about the existing solution here. So for data collaboration, we have a solution called Data Cleanroom. I'm not sure if you heard of it, but if you go to AWS, Azure, GCP, Snowflake, they usually have this kind of solution. So basically having another party, and then two parties go there together, and that party give you some kind of clean room so that you can only access the necessary data. But there are little bit of limitation that data clean room doesn't really guarantee like a privacy technology. So there's no behind privacy technology there. And also there isn't that much of transparency because clean room works as a third party, but they don't usually apply any encryption technology or privacy technology. And there is another technology called differential privacy. So it's a technology editing some noise. So for example, I have all the raw data. Let's say I'm the hospital. I have all the patient's information, or these patients have this cancer information, something like that. But if I just share that data as a raw data, it can be pretty risky and breaching the private information. So applying differential privacy, I'm editing a bit of noise, like faking the age. Let's say I'm 50, then with this technology, it's editing slightly noise like 51, 52, so that you are not really able to track down the actual individual. So that's called differential privacy. But because of the limitation of deep editing and noise, it doesn't also guarantee the transparency. So with TE, we usually provide all these kind of, technology enforced, privacy technology, and transparency. But the only limitation is because it uses the encryption on the backend, it may have some limitation with usability. So these are the current breakdown of existing solution. So Manatee is an open source project on the Linux Foundation. And we want to provide this kind of solution that giving you the tool protected by privacy technology and also giving you usability, accurate data, and also easy to deploy on the cloud side for data collaboration. So this is the diagram. So let's say I'm the data user, and they come to Manatee environment, and we basically give them programming stage so that they can actually play around with this stage. So it's a smaller data set, but it's a Jupyter interface. They can play around with the data. But once they understand what kind of data they are handling, they can go to the execution stage. So this is the TE environment. So once they put the job, then the job is executed in the confidential computing space that we are basically providing confidentiality and also attestation. So the attestation report comes out. Yeah, so why we are doing this way is because we want to separate the data policy and code policy. So for example, in this programming stage, we can give them not so raw data, but more like a synthetic data so that the user can actually play around with their data analytics with synthetic data. But once they are done with analytics, they can go to the TE environment, actually executing the confidentiality and attestation report. Yeah, so I think this part can be better explained when I go to the demo. Yeah, so use case is like this. So let's say we have a TikTok, like someone who has the data, and we want to share TikTok's data with government or with some research organization or with some other trusted organization. How can we share this data? So that's the challenge that we'd like to address with Manatee. So other use cases I will just skip. So for example, the researchers can come to the programming stage, and we basically provide the synthetic data, which is not real data, but they can still have some analytics. But now they are done with the analytics, they can go to the execution stage. Then we actually provide the actual data. Then that data job is done in confidential space. Then we give them attestation report. So with that attestation report, they can actually prove this analytics is done by confidential computing space. Yeah, so quick demo here is that in this demo, we use the data set from Kaggle, and we want to train a model. And also, we apply the privacy protection in the first stage, called like synthetic data, basically. So let me just quickly run this. So imagine this is your interface. So it's basically Jupyter interface. So let me click this. Yeah. So user goes to this interface, and they basically play around with the data. So firstly, they are going to install some dependencies here. So this is nothing different, actually, playing around in the Jupyter interface. So they basically call the data, and then they are able to get some data from the data owner. But this is actually not raw data. This is a synthetic data, like a somewhat fake result. Then they do their analytics. Then once they are done, they are moving to the second stage, which is the confidential computing stage. Then the job is submitted to the confidential computing space. Then as you can see, there's an output and attestation. So still the VM is running. Yeah, so they are checking the backend to see the log, and it says confidential space. So the job is done in the confidential space. So you can check the output. So this output is actually the real data, not the synthetic. So they can now see the actual analytics from the raw data. And once they verify this data, okay, this is good enough, then I really need to know if this is safe enough so that they can actually use the attestation, which I'm going next. So once they just verify, they run the AI model here, like XGBoost model. Once, yeah. Because it's now based on the real data. So this is what the data user wants to verify. So once this job is done, yeah, still the container is running on the backend. Then now, yeah. Actually moved a little faster. Yeah, so now this guy gets the report. Basically, it's a token. Then goes to, like this is just example, goes to JWT, and you'll see the hash value there. So the user basically comparing the hash from the confidential space to see they are identical. But in the body, there are actually more detail how this result came out. So make sure it's a confidential space. And also they are checking the container, if it's the right container the user should be using. And you see there are a lot of details here. So basically, with confidential computing, the hardware, the CPU key itself can prove a lot of stuff. For example, where this hardware was located. If it should be in Japan, it can put that location information here in this body. So the Azure user, okay, the token doesn't say it's Japan. And then you can see there might be some issue during the verification. And you can actually test like the hash value that actually the data output is same as confidential space so that you can see it's the identical. And you see somewhere here some cloud information so you can see which kind of cloud was running it. So now it says West to something. So and project name and ID. So this is one example. And another example is something about AI. So let's say in the programming stage, there's an evaluator. And I have the AI model. So I have my own private AI model. And then I want to prove this AI model is very good. But I don't want to share this with someone else. But from evaluator perspective, how can I run this evaluation script without having the direct access to your AI model? But you can use this for Manatee for this use case. So basically, model owner put the model in the confidential space, and the evaluator runs the scripts here. And from the confidential computing, you can only grant the permission to test the AI, but not able to see the AI model. So that's the feature that confidential computing can provide. So just okay, one more minute, so I'll just go fast. So basically, testing setup, what kind of AI model I'm going to test, and evaluation script. So here, basically, the user right now is downloading the evaluation script and also choose the model to evaluate. So that model could be provided from the AI model owner. So it's basically now running the evaluation and will submit the task. And once the job is done, as it's the same concept, you can download the attestation report. So next slide. Sorry, yeah. 1 second. So now attestation report should be available. Yeah, so basically downloading the output first, then going next. Yeah, basically checking the result because he wants to run the evaluation script. So he is testing the result, checking the result first. Then next, checking the attestation report here. I'll just skip some of it. Yeah, it's also same concept here that you see the, sorry. Yeah, so basically the concept here is that they can put the token here, like about hash result of your AI model, including the evaluation script, so that the user can see, okay, this is your AI model and also my evaluation script. So they can verify the result together. So I will skip this part. And just last slide here, so Manatee is on the Linux Foundation, and you can actually have more details, demo, and explanation under this QR. Yeah, so feel free to check it out. And I'll be staying around during the lunchtime and entire event. So feel free to reach out if you have any questions. Thank you.